on Fun with Felsic by Chris Hockett and guest star Emily Palmer. We're going to talk about the Chalice Volcano episode. Now, the Chalice Volcano episode happened about 52 to 39 million years ago during the Eocene era, with the bulk of its eruptions around 51 to 45 million years ago. Now, this volcanic action took place in the heart of Idaho.
What are the primary rock types in this geological province, and how did they form?
Well, that's a very good question, Emily. Now, the primary rock types in this area were intermediate, mafic, rhyolitic, and other types of tuft and pyroclastic flows. Thank you, Miss Palmer. Okay, do you have another question for me?
I do. What is the primary ages of the rocks in this geological province, and what are those based upon?
Well, the geological rocks were the tuft, the rhyolite, and the basalt flows that we just talked about.
How can you tell how old they are?
You can do this through radiometric dating or by other things such as superposition and other geological features.
What are the major structural features in this geological province?
Well, mainly there's rift and griffins, along with extensional basin and volcanic regions.
How is this present topography of this province related to its geological history?
Well, in the geological history, there's been tons of stretching, rifting, volcanoes, trans-chalice fault lines, as we can see in this depiction right here. Right here, we can see what used to be Washington, Oregon, and now Idaho. Back in the day, the continental edge used to go like this. And in this area, we had plates that were fighting for dominance in this area. We had the Kula plate and the Farallon plate. Well, the Farallon plate was winning this fight between the two, but as we had the divergent boundary right here in this area where these two plates were separating, it went underneath this land base right here and caused, as it went underneath, the plates started to melt, coming down underneath the area where the Chalice volcanoes are now, creating a magma pocket, and then starting to grow. And as it grew, this type of rock was mainly felsic rock. And so felsic rock was a little bit sticky and tended to cause a plug. So a big plug formed right in here, felsic rock. And so these volcanoes became very explosive. They threw stuff everywhere as they went off. Ash started to build up and created most of the sedimentary rock that we have in this area right in here now. Also, as this plate subducted and created these hot pockets that made these volcanoes right here, we had the Farallon plate, which eventually took over the Kula plate. And as it did, it caused this fault right here to break. And all this area right here moved up.
What natural resources, i.e. mining, water, energy, etc., and or natural hazards are related to the geology of this province?
Well, because of this volcanic activity that they had, it created lots of areas for gold, zinc, lead, copper, silver, feldspar, uranium. All types of things happen whenever you have this type of volcanic
Action.
area. Yeah, action.
What can you make out of that stuff?
Lots of rocks. Oh, you mean out of the copper and stuff? You can make all kinds of things with that. There's lots of mining in Idaho. Used to be a gold-rich area. They have ghost mines up in the northern areas.
What's your favorite type of rock?
My favorite type of rock would have to be the Felsic, because that stuff is sticky and strong and light colored. And very explosive.
It's a lot like you.
It's a lot like me.
That's all the questions I have for you today, Mr. Hockett. Is there anything you can add to this geological
So in
spectrum?
this area, we find lots of mountains, dips, cones, volcanic cones, uplifting of the plates, and basalt flows from the volcanoes themselves. Because of this area, we can get hydrodynamic energy and all kinds of other things because of the heat area that's going on underneath that. Well, that's all we have today on Fun with Felsic. Actually, probably